This is section 1.3, day 4, and today we're going to move into what's called some extrema of functions and then even and odd qualities of functions. So there are two different types of, well, I shouldn't say that. Some functions can be classified into two different types. Not everybody fits this mold, but two of the types are called even and odd. So even functions are symmetric over the y-axis, meaning if you see a part on that side, you're also going to see a part on that side. So our absolute value functions fit this. Our parabolas, as long as they are based around the y-axis, fit this. There are a variety of functions that fit as long as you are symmetric around the y-axis. So kind of that butterfly effect, if you fold it up, it's the same on both sides. Odd functions are symmetric around the origin, which means if I have one piece in the upper right-hand corner, then I have to have a matching piece in the lower left. So they have to be diagonal from each other and then mirror images of each other. So that's an odd function. So some students will say, does that just mean it always has an odd power? Not always. We're going to do a function later that will show you how to figure that out, but it's not always as simple as knowing, well, the parabola is squared, that's an even, so it must be an even function. Not necessarily, because I could move the parabola off of this y-axis and I could have one over here and that would not be an even function. An absolute value actually looks like this, and technically the power on that is a 1. So you can't just look at the function and say, well, I know if it is even or odd. So that was symmetric around the y, symmetric around the origin, kind of diagonally. My lights went off. And then what happens if a function is symmetric around the x, which just means if I had one piece up here, then I also have a piece down here. And the problem is it is not a function. So it fails the vertical line test. I can't spell and talk at the same time. Not a function. So that's why we don't talk about anything being symmetric around the x-axis. So there are tests for even and odd, ways that you can determine it if it is one or the other without looking at a picture. Although looking at it is the easiest way to do it. So if you wanted to test to see if something is even, it just means that if you were to plug in a negative value, you would get out a positive. So what that means is if I plug in positive 2, I get out this number. If I plug in negative 2, I get out the exact same thing. So whether or not I plug in a positive or negative, I end up getting the exact same y value. In an odd function, it actually has to be opposite. If I were to plug in a negative number, I should get the opposite of the function. So instead of being up here, I should get the exact opposite corner. So it should flip in sign. So the overall gist here is if you plug in a negative, see what happens. Are you the original function? That's even. Are you the opposite? That's odd. So here's a function, and x to the fourth minus an absolute value of x, and is that even or odd? So we're going to do it both ways. I'm going to show it to you algebraically, and then I'm going to show it to you graphically. So algebraically, we are going to plug in a negative. So everywhere there is an x, we're going to put in a negative x. So that means I'm going to have negative x to the fourth minus negative absolute value of x. And if I raise something to the fourth power, that means there are 4 of them. And every 2 of them, my negatives will cancel out. So it's kind of like having negative x and negative x and negative x and negative x, and I got to squeeze in a negative absolute value. So every 2 of these, they're going to click each other out, and I really just ended up with positive again, x to the fourth. And then I just have that subtraction sign, and then absolute value does its job, which is just to turn anything positive. So even if I were to put a negative x in there, it would just come out as a positive x, and I have the exact same function back. So this is an even function. I plugged in a negative number. Sorry, I plugged in a negative x. I simplified, and I got back the exact same function. So this is going to be an even. So let's go ahead and graph it just to make sure. We're going to go back to our y equals. I'm going to do x to the fourth, so I'm going to type in my x button right here. And then to do to the fourth, you can use this little arrow button, and then type a 4. And then make sure that you arrow off of that. So I'm going to hit this arrow, kind of drop my cursor back down so I can keep typing. Minus, and then absolute value is found by hitting the math menu. So this button right here. And if we go over to number, the very first choice is ABS, which is absolute value. So if I hit enter, some calculators will throw up the vertical line so you know it's absolute value. Some of them actually write ABS and then have a parenthesis. So in either case, you should either see the vertical lines or you should see ABS. And then we're just going to throw an X in there. And then I'm going to always hit zoom 6, remember, so that you get back to that standard window. And there's my function. And it does look like an even. I'm not sure what this is all about down here, so I'm just going to show you how to zoom in real quick so you can take a little closer look. So if I hit zoom and then in, and before you hit anything else, you see how there's a flashing square there. If I just move my cursor for a second, it's actually my cursor was sitting in there, and it kind of starts at 0, 0 because duh, that's where it's going to start. But you can move it around and decide where you want to zoom in, or had you chosen zoom out, same thing. So imagine you're on Google Maps and you want to zoom in on a particular location. You kind of go to that spot and zoom in. So your calculator offers you that same option. You can kind of move your cursor if you needed to, but I kind of want to zoom in there anyway, so I'm just going to hit enter so that it actually zooms in. And there it is zoomed in. So it looks like a nice W. Looks like I have the exact same amount on both sides. If I were to fold that in half, it is the same both ways. So I'm just going to give myself a sketch so I can remember what it looked like for later. It just kind of looks something like this. And that is an even function because if I were to fold it in half, I got the same on both sides. A couple more. Are these functions even, odd, or neither? We're definitely going to graph them, but I'm also going to do them algebraically with you just so you can see the math. So if we did a negative plugged in, I would have a negative x cubed, and then I would have a negative x. So a negative to a cubed power is actually going to be that function, or that value, but negative, because 2 of those will cancel each other out, but I'll have an odd one left over. And then this negative and that negative will turn positive. So in this case, I don't have the exact same thing I started with. I actually have the exact opposite. This was positive, now it's negative. This was negative, now it's positive. If everything switches, then this is an odd function. Next one, h of negative x. We're going to plug a negative in everywhere and see what happens. So if I have a negative x and I cube it, just like up there, I'm still going to end up with a negative x cubed. And then I just have this minus 1. There was nothing to plug in there, so no way that was going to change. It did not stay the same. That was positive. This is now negative. So that switched, but then this negative 1 stayed negative 1. So I have one that switched and one that didn't. So this is actually a neither. But a really good example for, you can't just look at that and say, oh, it's cubed, that's an odd, it must be an odd function. You can actually create ones that don't fit either mold just based on the exponent. So make sure that you either plug in the negative or give it a graph real quick so that you can take a look at it. So this one is x cubed minus x. Oops, I didn't hit my zoom 6. We can actually use that though. So this, for it to be an odd function, remember diagonally it has to be the same. So I've got kind of a little loop here, same in the opposite corner. And then in this corner I've got that portion, and then in this corner I've got its match. So as long as you see the exact same thing diagonally, that's an odd function. The other one just turned this into a minus 1. And there's my function, and it does not have the same things in this corner as that corner. This corner has a piece, this corner has nothing. So that's definitely not an odd. It's definitely not even, because the amount that I have over here is not a mirror image on this side. So that is why it is a neither. A little more calculator work here at the end. We're going to teach you about something called a relative max and min. So I've got this function in x cubed. We're going to go ahead and type it in. So x to the third minus 3x squared plus 2. I'm going to do my zoom 6, kind of set it back to standard, and there is my function. So then it's asking me, can I please find the relative max and the relative min? And the reason it's called relative is because we know that this function goes up forever. So does it technically have a maximum? No, because it's going to infinity. It also technically does not have a minimum because that's going to negative infinity. So what we call relative are any of the bumps, because this is a high point. This is a low point, although I know it's not the absolute high or the absolute low. So when we're doing a relative max or min, we're really just talking about the bumps. We're talking about those intermediate kind of highs and lows. And your calculator will actually calculate those for you, and that's what I'm going to show you today. And you're probably going to want to write down a lot of the keystrokes. So make sure you pause this video a lot, because there's going to be a lot of different things that I hit on the calculator to get you to those spots. So let's do our relative max first. So that's this high point right here. So I'm going to hit the second button, which is right there, and then I'm going to hit calculate. And your fourth option is max, and if you look right above that, it's going to be min, so we'll come back in a minute and do our min, and that'll be the button we use. So I'm going to hit enter. First thing your calculator asks you is left bound. So what your calculator is asking you is, can you please tell me from where to where should I look for this high point? So your calculator needs you to define the parameters, kind of the window where it's going to look for a high place, because it knows darn well that there's a high place over here. So it's asking, over what period of time, over what x values do you want me to look to try and find a high spot? So we are on our high spot, so I'm just going to move left of it. It doesn't really matter where you are in there. You don't want to be too far away from the highest point. So just kind of go a couple notches off. It's asking you left bound question mark. So it's saying, where do you want me to start on the left? Where should I start looking? So I'm going to hit enter. And then if you look, it kind of threw up a little triangle. So it's saying this is the point where I'm going to start looking on the left. So it's kind of like your left bound. I'm going to start looking there. Then it switches to right away. So we need to move our cursor until I get on the right side of that bump. Again, it doesn't really matter, you know, how high or how low you are. You just want to be a couple little clicks off of that high spot. And I'm going to hit enter, and as soon as I do, it puts up the other triangle. So your calculator has said, all right, I got it. You want me to look for the highest place in between these two triangles. So I'm going to go ahead, and if your calculator offers you the opportunity to take a guess, would you like to guess at what the high point is? We have better things to do with our time. So just hit enter. And it's going to put the cursor right at the top, and it's going to tell you that it is the maximum at this value. So now you look at your calculator and go, okay, are you lying to me? Because I don't know that every single person just got 1.9 times e to the negative sixth. When I do this in class, we often come up with many different answers here because all of our calculators are a little different. But if you really look down at this value, it has this e to the negative sixth. And that is telling you scientific notation that you learned a long time ago. So it's really saying times 10 to the negative sixth. And what it's saying is you take your 1.9 and you're going to move the decimal place over 5 times. So 1, 2, 3, 4, 5, 1, 9, and then the rest of the decimal, which for our purposes is essentially 0. So our maximum is at 0, and then our y value is 2. Also kind of a gut check, if I see 1.9 and I'm looking at this going, wait a minute, that's not over at 1.9. Something should kind of be tipping you off. That dot's got to match whatever it gave you for a value. So make sure you're scanning the whole number so that you don't miss kind of something subtle like that, like a times 10 to the negative. Let's repeat the whole process. This time we're going to do our minimum. So second, calculate. This time we're selecting number 3, minimum. Same process. So we know our minimum is like there somewhere. So I'm just going to get on the left side of it a couple notches. I'm going to hit enter. Up goes the triangle. Right bound, I'm going to get on the right side of it. A couple clicks. Hit enter. Up goes the triangle. So I'm just kind of double checking, is my low point in between those two triangles? Sure is. It wants me to take a guess. I'm just going to hit enter. And it should put the cursor at the bottom, and it's going to give me the value. So this time it gives me a value of 1.99985. For our intents and purposes, that is just 2. We don't need to write all those decimals. And my y value is at negative 2. Okay? And that actually matches visually. It looks like I went over some and I went down some. So at least those numbers don't have an e to the. I don't have to worry about adjusting for that. So now that I found the max and min, I can do increasing, decreasing, and constant. So if I asked you to put your finger on this graph, and we're going to trace it from left to right, just like you normally read a graph. Right now my finger would be increasing, then I would be decreasing, and then I would be increasing. And we're going to talk about those places where that happens. Increasing, decreasing, and constant are always off the x values. And constant, just so you know, is if there was any place on the graph that was totally horizontal. We don't have any on this one. You won't always have constant sections, but if you do, it's just where they are totally horizontal. So our first part of this graph is increasing. And this is off x value. So imagine that that has gone down and over forever. So it started increasing at negative infinity. And it increases all the way until it hits this high point. And because we see the words max and min, students will often use the y values. Make sure that you are always using x values. The only time you're going to use a y value is when you're doing the range, okay? So your x values, they increased all the way until 0. So that x value right there where I increased was 0. Then I decreased, and I started decreasing at that exact same moment of 0, and I decreased all the way to that value, which happened at 2. That's why it's handy to have your max and min done first, because then you're just going to use the x values to do your increasing, decreasing. And then I started increasing again from 2, and it looks like I'm going up and out forever, so that's to infinity, so we'll go from 2 to infinity. And as you're doing increasing, decreasing, constant, just check your numbers. You should overlap just a little bit. So your x's should be the only numbers I see here. I shouldn't see y values in all this mumbo jumbo. And then just take your finger and go, I had 1 increasing, I had 1 decreasing, and I had another increasing. So did I have 2 increases? Yep, and 1 decrease. So I've kind of got all my parts accounted for. And there was no constant portion in this particular graph. So a lot of different pieces, especially on the calculator. Make sure you probably go back and write down some keystrokes, like what we hit in order to get there. We started off with even and odd. Can't just determine it off of the power of a function. You got to do some testing for it or visually look at it. And then with your max and min, you always want to find those two first so that you can use them for your increasing and decreasing and constant.